I'm gonna record this. So then I'll put this one on YouTube if anybody needs to see it again. So today we're learning two formulas. We're learning distance and midpoint, and this is something that you should have learned in Algebra 1. Again, I think I've told you, I assume you remember nothing from Algebra 1, so if you don't remember that, that's okay, but this should be a review. First, we're gonna practice simplifying radicals. So if you can divide any perfect squares out of a radical, then it's not simplified. I call this making it a little factor tree. I don't know what your algebra teachers have called it in the past, but we make a little tree to see what factors go into the number that's under my radical. So I have root 54. I start with 2, 3, 5, 7, some prime numbers. I'm gonna start with 2 and see what divides out evenly. This becomes 27, I think. And then I go again, see what else I can divide out. Okay, that becomes 3 and 9. Cool. And then 9 becomes 3 and 3. So all of these numbers are at the end of their little diagram. Those are the numbers I'm looking at. And we want to see if any match. I have 3 and 3. Those guys match. That's it. So those get to come out of the radical. They go in the front of the radical. So I get to write 3. And then what stays in the radical are the numbers I didn't highlight that don't have matches. I have 2 and I have 3. So I'm going to do 2 times 3. When you have more than one number under the radical or more than one number outside the radical, you multiply those two numbers together. So 2 times 3 is 6, so I've got 3 root 6. And so the most simplified way of writing root 54 is 3 root 6. All right. Let's look at the next one. Next one is root 360, so we're gonna do that factor tree. You can start with 2 or 5 or 3, etc. But I actually know a bigger number that I know perfectly divides. If you have a 0 at the end of your number, you know it evenly divides by 10. So I'm going to take 10 out, and I'm left with 10 and 36. 10 we know can break down to 2 and 5, and 36 breaks down to 6 and 6. Now, I know that 6 can also break down and break down and break down. However, what I also know, though, is that 6 is already a pair, it already is a match. So if that's already a match, I'm not going to go any farther. I have 6, 6, 2, and 5. 6 is my perfect match that gets to come out. And then what's left is 2 times 5. Again, like I said, we multiply them. The better we get at this, the more advanced we get with our math. You don't need to have this 2 times 5 step. You can just go directly to 6 root 10. 6 root 10 is my final answer on that. Okay, any questions so far? Any questions? Nope, okay. Now I'm gonna go in and do the distance formula. So we just practiced simplifying radicals because I'm gonna use that in order to finish my distance formula. Distance formula is a formula that tells me how long something is or the distance between 2 points. This is something we teach almost every year at the beginning of the year. We teach in Algebra 1, we teach in Algebra 2, we teach in geometry, and I literally just taught my pre-cal kids this as well. So this is a common skill that we learn, and so I totally understand if you don't remember it from Algebra 1, but I'm telling you it comes up and comes up and comes up and comes up. So we are gonna learn it again today. You need to have at least 2 points, x1, y1, and x2, y2. And once you have those 2 points, then we plug it into my formula. It doesn't matter if you put your x1 or your x2 first, as long as you're consistent. So some teachers teach it like x1 minus x2 squared, and then plus y1 minus y2 squared. As long as it's consistent, both either the second point first or the first point first, I don't care. The other thing is it needs to be minus, 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 minus. Okay? All right, so this is all fun and games. Let's talk about this as an example. So the example that's given to us is SR has endpoints -2, 14, and R is 3, -1. And we want to find SR. Remember, when it's just SR without a hat, that means my length / distance. And so we've done it with length when I've given you length, like it's the length is 17 or the length is 4 or something like that. Now we have to find the length. And when we find it, we call it our distance. We're finding the distance between them. So I'm going to label my points. I'm going to label it, let's say x1, y1, and then x2, y2. And I'm going to use my distance formula to plug in. So I'm going to do my x2, which is 3, minus my x1, which is -2, square that, and then plus y2, which is -1, minus y1, which is 14. Square that, square root. Okay, you can't see my formula anymore because I have to zoom in so I can write kind of nice. 3 minus -2 squared plus -1 minus 14 squared. I made a big point to write minus negative because I wanted to show you that we have to minus these 2 points. And then now I know minus negative is the same thing as plus a positive, so I can just make that one big plus. So I've got root 3 plus 2 is going to be 5, so 5 squared. And then -1 minus 14 is -15 squared. 5 squared is 25. And then remember that -15 squared, or really anything negative squared, is always going to be a positive. Negative times a negative becomes a positive. So -15 squared becomes a positive 225. All right, let's add them together. 25 plus 225 is going to be root 250. Ooh, nice. And we just practiced simplifying radicals because I want us to simplify this radical too. So let's make a little factor tree. 250, whoa, let me zoom in. There we go. Becomes 10 and 25. 10 becomes 2 times 5, and 25 becomes 5 times 5. If these are my factors, oh, I have 5 written twice, awesome. So I can take 5 out, and I'm left with 2 times 5, or 10 on the inside. So what I'm saying here is that SR is equal to 5 root 10. And actually, let me write that. SR equals 5 root 10. All right, any questions so far? Okay, we're going to do another distance practice problem in a minute, but I'm going to teach you one more formula and we're going to practice that a couple times. This one is called midpoint formula. So we've learned about midpoints on a picture in geometry, and it just means the point halfway between the endpoints of its segment. So the point halfway or in the middle is called my midpoint, and we learned that last week. And you guys were good at it. Let's say I had a segment. Let's say I called it A, C, and I had a midpoint at B. You guys knew that A, B, and BC were the same. And so I could give you like the total length or the length between the A and the B, and you knew how to find the other things. That's awesome. What we're going to do now, though, is if I give you coordinate points for A and C, we can find B. So if I give you point A is just generally x1, y1, and point B is x2, y2, then we know that the midpoint formula, you can find the midpoint by doing x1 plus x2 divided by 2, and y1 plus y2 divided by 2. The biggest thing is to remember these are plus signs. This is something even like my seniors forget in pre-cal. They want them to be minus because we minus a lot. Nope, these are plus signs. I want you to think of this as the average of the x's and the y's. Remember, if you're averaging your test score, if you're like, okay, these are all the quizzes, what's my quiz average? You add them up and divide by how many there are. There are 2 points here, so to average them, we're going to add up the x's, divide by 2. Add up the y's, divide by 2. Okay? Again, it's all fun and games until we try it, so let's do an example. I'm going to label this first point. Okay, the directions say, find the coordinates of the midpoint of the segment whose endpoints are given. So these are both the endpoints, and we want to find the midpoint, which is my hint to use that formula. So I'm going to label my points x1, y1, x2, y2, and I'm going to plug it into that formula. Let's see if I can zoom out enough to see the formula. So I'll do x1 plus x2, so 4 plus 1 divided by 2, and then I'll do y1 plus y2, which is -4 plus 7 divided by 2. Notice there's no equal sign in here. There's no x equals. Your answer is not one number. It's going to be two numbers as an, excuse me, it's an ordered pair. It's a coordinate point. So my answer here is going to be in the form of like in parentheses, something, comma, something else. I've got my x1, 4 plus x2, which is 1. And I've got my y1 plus, which is -4 plus y2, which is +7. And again, my answer, I'm just writing this in case I forget and need to look later, should be an ordered pair. It should be x comma y, one number comma another number, okay? Now I'm going to divide. I'm going to do 4 plus, or I'm going to add them and then divide. 4 plus 1 divided by 2 is just 5/2. And then -4 plus 7 is 3/2. This is a perfectly acceptable answer, and I personally really like fractions more than I like decimals, but decimals are not incorrect. So if you immediately reached for your calculator or plugged it in and got a decimal, then this is also an acceptable answer, 2.5, 1.5. Both of those are just as correct as the other one. All right, questions so far? All right, okay, let's try the next one. It's the exact same idea. I'm gonna label my points and I'm gonna set it up. So I've got x1, y1, I've got x2, y2. Plug it into our formula. 2 plus -3/2, and then 9 plus 6/2. Remember, we're adding plus, plus. All right, let me close my parentheses and let's add them. 2 plus -3 is going to be -1/2. And then 9 plus 6 is going to be 15/2. Again, you can leave those as fractions or you can make them decimals, totally fine by me either way. -0.5, and then I think this is going to be 7.5. Those would be my answers. Now you can get whole numbers here, we just didn't. So you could actually get real numbers like -2 and 4 or 7 and 10, I don't know. But we just ended up getting decimals on both of these. Okay. All right, next problem is if I give you the coordinates of the endpoint and I want you to find me the midpoint. Coordinates of the endpoint and we want to find the midpoint. So this is different than the other one. This says the midpoint of KL is M. All right, time out, let's draw it. KL is a line and M is my midpoint, so it's right in the middle. We know those segments are congruent to each other, blah, blah, blah. What we also know is that M is at 6, -2. So I'm going to label M at 6, -2. And then the other thing I know is K is at 4, 3. What I don't know is where L is, and that's what I have to find out. I'm going to label L right now as X2, Y2. I don't know those points. I know I have to find them, but I don't know them. This is different than the problems we just practiced because I gave you 2 endpoints and then we found the midpoint. It says find the midpoint. This time we have to find one of the endpoints after I gave you the midpoint. Okay? I'm still averaging the endpoints. I'm still averaging this and this, and then they equal this number right here. And so that's exactly how we're going to write it. It equals the midpoint. So I'm going to write 6, -2 by itself on the left side of my equation. On the right side, I'm going to do x1, x2. My x1 is my k. It's my 4 and my 3. So I'm going to average the x's and the y's of k and l. We know k is 4, and we don't know l, so we're going to use x2. I know that k is at, its y is 3, but I don't know where l is, so I'm going to call it y2. Now I have an equation where I necessarily didn't the last time. I've got the midpoint, and you can think of it this way. You can think midpoint is equal to the average of endpoints. So just because I gave you a point for the midpoint doesn't mean it gets to go into the average. It gets to stay by itself. Now you might be like, okay, Miss White, I see how you set it up, but like now I don't know what to do. Well, now you have to set the x's equal to each other. I have x values, 6, and then 4 plus something divided by 2 should equal each other. And then I have y values. I have -2, and then this 3 plus some number divided by 2, those guys should equal themselves. So I'm going to set up two equations like that. I'm going to say 6 equals 4 plus x2 divided by 2. That's one equation. That's going to help me find my x value. And then I'm going to do the same thing for the y's. I'm going to say negative 2 equals 3 plus y2 over 2. We okay with that? Okay, so let's solve. Now, I don't want any fractions if I can help it. So I'm going to multiply 2, or you can even think of it as 2 over 1 to both sides. So I can get rid of that 2 in the denominator, which leaves me with 4 plus x2 in the right side, and it leaves me with 12 on the left side. I'm going to minus 4 from both sides. That gives me 8 equals x2. All right, that gives me one answer. That's good. Similarly, you solve the exact same way on the other side. We're going to get rid of the fraction, and then you're going to get that y by itself. So I'm going to multiply by 2, or again, 2 over 1. Whichever makes you happy. They mean the same thing. I get 3 plus y2 on the right side, and I get negative 4 on the left side. Minus 3 from both sides, I get negative 7 equals y2. Now, just like when we found the midpoint, my answer here is also a coordinate point. You can think, going back to my diagram, I can think that x2 now is 8. And I can know that that y2 is now negative 7. So you can think of it like that's my point that we just found. And so I'm going to write it nice and neatly as in L equals 8 comma negative 7. Okay, we found a point. That was my goal. Found a point using my midpoints. All right, any questions? Let's do another one. Same idea. Same idea. And I'm going to draw another picture because when in doubt, we draw. Draw and label like I've kept saying for days and days and days. All right, I know my midpoint is M and I know my endpoint is P. I don't know my other endpoint. You can use whatever letter you want to use to represent it. I'm just going to use a basic X. And I'm going to label my P and M with the points that's given to me. So P is 6, negative 4. And M is 3, 10. And we don't know what X is, so I'm going to call that X2, Y2. And then again, we're going to plug it in. Plug it in just like we did above. The biggest thing to recognize is which one's the midpoint and which one is the endpoint. So in this case, my 310 is my midpoint. So I'm going to let that be by itself on the left side of the equation. I've got 310 by itself over here. And then on the right side that I have my equation kind of set up, I'm going to do 6 and x2 and negative 4 and y2. 6 plus x2, negative 4 plus y2. Everyone good so far? Okay, set them equal. I'm going to set my y's equal to each other just like I did before, and I'm going to set my x's equal to each other just like I did before. 6, oh nope, let me write 3 equals 6 plus x2 over 2. I'm going to multiply by 2 on both sides. Don't know what happened there. Gives me 6 equals 6 plus x2 minus 6 from both sides. Oh, 0 equals x2. Can 0 be a coordinate? There's 0 on the number line. There's 0 on your graph, right? It's just like here on the x-axis. Those are 0 coordinates. So we can have a 0. That's cool. It's not always what we get, but it's okay. And then I'm going to do 10 and negative 4 plus y2. 10 equals negative 4 plus y2 over 2. Again, multiply by 2 or 2 over 1. 20 equals negative 4 plus y2. Add 4 to both sides. 24 equals y2. Again, that's kind of a weird number, but it's not possible. We could have positive 24 on my y-axis. It just would be a really tall number. So I'm going to say my point x is going to be at the point 0, 24. And I use my midpoint and my other endpoint to help me find that. All right, doing okay? Remember to tell me if you're not.
Does it always have to be in, does it have to be in a certain order every time when you set up the line?
The endpoints do not have to be in a certain order.
So like if we had like 3, 10, not like on the other side, would that give us the same answer?
Oh, you mean like on the right side of the equation versus the left side?
Yeah, and then if like we put a different one equal to?
That should be fine, but I may have to look at exactly what you're saying tomorrow. Okay?
Okay.
Okay. The only thing that really matters is the x's go together and the y's go together. So you can't mix those, but most other than that, it's okay if you switch some of the plussing and on the different sides of the equal sign. That should be fine. All right, the last problem I think we're gonna have time for is this last one. It says find A, B, and B, C. Remember when they don't have little hats, then they are meant to be length / distance. And so we're going to use our distance formula that's like further up on your notes. I'm not going to zoom back. I just remember it because I do it all the time. But if you don't remember it, flip your paper over and look at it. Remember that distance is x2 minus x1 squared plus y2 minus y1 squared. And so I have to find the distance for AB and BC. So I'm going to label my points. I can call A x1, y1, and I'm going to call B x2, y2. And I'm going to first find AB, the distance of AB. So we're just essentially plugging and chugging. Do x2 minus x1, 3 minus -2 squared, and then y2 minus y1 squared, 1 minus 4 squared. So let me write that down. I've got 3 minus -2 squared. Again, I write minus and negative to remind myself that I'm doing minus the points, squared, and then I'm doing plus 1 minus 4 squared. 1 minus 4. All right, now let's do some math. 3 minus -2 is like 3 plus 2 is 5 squared, and then 1 minus 4 is like 1 plus -4 or -3. Remember, squaring is always positive. 5 squared is 25, 3 squared is 9, and then I can add them. 25 plus 9 is 34. Okay. Are we all right with that? Okay. All right, now I'm going to do the other one. The next one says BC. So I'm just going to keep B where it's at. I'm going to keep it as your x2, x1, or sorry, y, x2, y2. Whew, letters are hard already this morning. C, I'm just going to label x1, y1. I know that's what I labeled A, but it's a new problem, so it doesn't matter how I label it. So I'm just going to plug it right into my formula. Again, like I said, it doesn't really matter which one it is. So I'll do 3 minus 0 and then 1 minus -4. BC. 3 minus 0 squared plus 1 minus -4 squared. We okay with the setup? 3 minus 0 squared is 3 squared. And then 1 minus -4 is like 1 plus 4 or 5 squared. Okay, 3 squared is 9, that's easy. 5 squared is 25, that's easy. Add them up, 9 plus 25 is 34. My big question was, are they congruent? Do I have enough information here to tell me if they're congruent or not? What does congruent mean again? It's been a long weekend, I don't remember. What's congruent mean? Anybody? You're a little shy? That's okay. It means the same length. Do these have the same length? Yeah, good. I see some nodding. Awesome. They have the same length. These are the same number. They're the same length. So I'm going to say, yes, they're congruent. And you can write this a couple ways. I can write AB is equal to BC. Remember, when they don't have hats, that means their number AB, the length AB, and the length BC. Or I can write the segment AB is congruent to segment BC. When I put little hats on them, that means the object. And objects are not equal, they are congruent. All right, we'll do some practicing simplifying radicals maybe tomorrow, maybe Wednesday. We'll just see what I feel like. I'm gonna stop sharing now. If you guys have any questions, feel free to visit me during Flex. If not, have a great rest of your day, and it's good to see you virtually, and I'll see you tomorrow in class. Okay? Bye, guys.
Thank you.
Thank you.